Welcome to click on this video. I am Yunhao Fu, a PhD candidate at University of New South Wales, Sydney, Australia. This video will briefly describe the design of a compact omnidirectional Leaky-Wave antenna fed by higher order mode. A Leaky-Wave antenna is a waveguiding structure radiating energy along propagation. In Figure 1, based on subsequent boundary condition, when a leaky mode transmits along the positive z-axis, a beam is formed, pointing at a certain angle. Generally, a TE10 mode in rectangular waveguide is considered, and then modification is conducted to transfer it into a leaky mode. Figure 2 shows the surface current of TE10 mode. On the top wall, the current is symmetric to the midline, and on the side wall, it is only flowing vertically. Figure 3 shows the surface current of the employed mode, and it is the TM11 mode. In comparison, it has such advantages. First, due to the longitudinal surface currents of the TM11 mode, the power leaking via transverse slots will produce radiation with low cross-polarization in both E and H plane. Secondly, it is equivalent to an antenna array of 4 elements with identical surface currents, having the potential of omnidirectional radiation patterns. In Figure 4, transverse slots are etched on 4 walls for radiation. In Figure 5, the dashed line stands for Leaky-Wave antenna with identical slots, and there is an obvious side lobe close to the main beam. To suppress the side lobe, attenuation versus slot dimension is conducted in Figure 6a. Minus 25 dB Taylor amplitude distribution is adopted, and then mapping between the required attenuation and the slot dimension is conducted in Figure 6b. Finally, only one beam is observed as a solid line in Figure 5. More importantly, the level of cross-polarization in both cases is significantly low. The proposed antenna can be realized by PCB sections as shown in Figure 7, and the assembled antenna with fixture for measurement is shown in Figure 8. Radiation patterns are presented in Figure 9. In the elevation plane, the beam is steered with frequencies, and in the azimuth plane, omnidirectional radiation patterns are achieved in this single antenna. For more information, please refer to our published work. Thank you for watching this video.
This video will briefly introduce hybrid T cylindrical leaky waves, electromagnetic radiation at broadside from radially periodic structures. The relevant work can be found in IEEE transactions on antennas and propagation. If properly excited, broadside radiation can be excited by means of a horizontal magnetic dipole, but the dispersion of the linearized structure only predicts a TM wave. On the other hand, based on cylindrical leaky wave theory, only a TM wave cannot support broadside radiation, thus creating a sort of paradox of the radiation mechanism in radially periodic structures. To understand the reason for such a discrepancy, we investigated the role of the T component of the excited field. We discovered that the algebraic radial decay factors of the fields are different. This is a clear indication that the T component is non-negligible, and it cannot be described by the n is equal to 1 T cylindrical leaky waves that would exist in a uniform structure. To further investigate the role of the T component, a generalized pencil of functions analysis is then performed. It can be seen that the extracted Tm and T wave numbers are in excellent agreement, which proves that we have a single cylindrical leaky mode having a hybrid TM-T nature. As concerns the amplitudes, we may conclude that the relative importance of the T component is greatly increased around the broadside frequency. By theoretical deduction, we found that due to the azimuthal dependence of the field, coupling between the T and Tm polarization is always presented by the ring curvature. Based on this, an approximate current model is derived, which consists of a profile function related to the current behavior inside the unit and a modulation function related to the cylindrical spreading of the waves along the antenna surface. And finally, the far electric field radiated by the surface current can be obtained by reciprocity. To validate the proposed models, comparisons with full wave results for both the surface currents and the radiated far fields have been performed. As shown, the proposed model provides better accuracy than the traditional model with only the single TM wave, thus confirming the generality of the adopted approach. We believe this work sheds new light on the nature of the general class of radially periodic structures, which are very interesting as they can provide high-gain broadside radiation with simple and planar structures. Thanks for watching. Please contact us for any follow-up questions.
Hello, everyone. I'm glad to be here to share a recent research on beamforming scanning antennas. The topic is a leaky-wave antenna with capability of fixed-frequency beamforming scanning. These are the contents. Then we start from the background. Leaky-wave antenna, as a kind of traveling wave antenna, has attracted significant attention due to their high directivity, easy integration and low-profile characteristic. However, inherent frequency scanning characteristics and lack of flexible beam control property limit the development of leaky-wave antennas in fixed-frequency beam scanning. On the other hand, for beam scanning antennas, the recent research hotspots mainly focus on high-gain, wide-angle scanning, higher scan resolution, and so on. However, recent works are rarely pay attention to stability of the accepted electrical level and different scanning strategies in complex electromagnetic environment. To this end, in this work, we managed to propose an antenna integrated with two beam scanning capabilities simultaneously, which can provide users with more choices of scanning schemes for applications in complicated environments. Then let's introduce the continuous beam scanning and beamforming scanning. For leaky-wave antennas, if the dispersion characteristics of the leaky-wave structure can be changed, then beam scanning at fixed frequency can be realized. Thus, beam scanning can be easily realized if the period of the slot can be regulated according to the Formula 1 by using one row of slots. However, traditional beam scanning techniques are proposed for far-distance wave coverage and are not suitable for wave coverage in confined spaces or short-distance regions, such as tunnels or long straight corridors, where the constant field strength is expected when antenna beam scanning. Therefore, a new kind of antenna with the capability of cosecant squared beamforming scanning is proposed in this paper, which has the characteristics of providing large gain at low elevation angle direction and small gain at high elevation angle direction when scanning, so the target can receive almost the same signal level when moving along a straight confined path. The general principle of the hybrid coding method is to use the same or different codes to control two or more rows of slots, so each of them can generate a beam with required angle and strength for a beamforming. When the beam direction, theta, is relatively small, usually less than 20, a single row of slots is enough to generate required field strength. With the increasing of theta, it is difficult to achieve enough field strength required for beamforming by only one row of slots, so another row of slots is required to compensate the field strength. When theta is larger than a certain angle, usually larger than 30, two rows of slots with the same codes are used. Using this field compensation and hybrid coding method, we can not only get uniform radio wave coverage, but also improve the energy usage efficiency and reduce the electromagnetic pollution. Here show some results about proposed antennae, and it is found that beam scanning and beamforming scanning functions can be realized. Moreover, compared to the available beamforming antennas, the proposed antenna has capabilities of a wider beam coverage range, flexible beam switching, and broadside radiation, which is a preferable candidate for future smart wireless communication. Besides, the antenna proposed in this communication has two beam scanning capabilities simultaneously, which can provide users with more choices of scanning schemes for applications in complicated environments. Thanks for your listening.